I'm GigaRanD. My final year research project is open source tribrid ransomware detection system. First, I will explain the problem. Ransomware are one of the most dangerous malware in these days. Ransomware is a kind of malware that prevent user from accessing files in the system. There are two kind of ransomware. One is local and the other one is crypto ransomware. Local ransomware is locking the entire system so the user can't access the system. As an example, it is like a gate that won't take anyone inside until they pay the ransom. The crypto ransomware are the most dangerous kind of ransomware. Crypto ransomware encrypts the user files in the system. The system is accessible but the files are not. Anyone can't decrypt those encrypted files without the decryption key. The attackers are always asking for a ransom amount to give the decryption key. It's a huge amount that most of the users can't afford. What is happening in the most of the time is users are always formatting their entire system. They will never get back their data. According to a study done by Sophos Security in 2020, found that only 24% of victims were able to prevent ransomware attack on data clouds before the data cloud is encrypted. And the cybersecurity ventures predicts in 2021 a ransomware attack will happen on every 11 seconds. So that's the basic status of ransomware attacks. If we analyze the existing works done by other researchers, we can categorize them into three types. Those are pre-encryption detection, post-encryption detection, and real-time encryption detection. Pre-encryption systems are trying to detect the attacks before it begins. These kind of solutions are having less accuracy. Post-encryption detection and decryption systems are trying to recover the encryption key to decrypt the encrypted files. What those systems are doing is backup all the Windows library generators keys into a database. If there was an attack happened, the user can use those backup keys to decrypt the attack. Even if the user got the decryption key, it will take too much of time to decrypt the entire system because users need to decrypt those files one by one sometimes. In large organizations, it will cost more money than the time. Currently, these systems are able to back up the keys that are generated within the Windows crypto key generation service. If one of the ransomware used its own crypto library rather than Windows crypto key generation library to generate the encryption key, that key cannot be backed up. So in that time, post encryption decrypting systems are fail. Real-time detection is the one I am going to research and improve. Real-time detection systems are trying to detect the attack in real time while the attack is happening. These systems are more accurate than other two types of ransomware detection systems. Real-time detection systems are using machine learning the most of the time to detect attacks. Most of the existing works were improved the accuracy but not the performance. They were not focused the performance improvement. Those systems are not able to detect attacks before some number of files are got encrypted. The identified research gap is the lack of performance in real-time ransomware detection systems, which is not capable of detecting ransomware attacks in the early stage of encryption. From GigaRanD project, I was able to develop a more faster performing real-time ransomware detection system. Based on the literature review, I drew this concept map for the GigaRanD system. The red colored lines showing what I am going to research and improve. The architecture of the system is have three tiers, that is presentation tier, logic tier and the data tier. The presentation tier is the UI that alert the user about the detected attacks. The logic tier is the machine learning based system that will analyze and detect the attack, and the data tier is the temporary data storage that store the captured events. Now I am going to show you how the GigaRanD tool is working. I've created a Windows 10 virtual machine for that. Since ransomware is too dangerous, we can't test those in a physical personal machine. Here we can see the GigaRanD tool and the payload applications. The payload is a sample ransomware I previously downloaded for the testing purpose. This is the tool I developed. From these buttons on the top of the application, we can start, stop and control the application. When the application is in running mode, it will show all the Windows activities in this table. If we want to filter the activities, we can use this filter section. Also, there is an option to save the captured data to a CSV file. I previously ran my application on several Windows 10 machines and collected data for the machine learning model. If we look at the downloads folder, here we can see there are few files. Now I am going to start the GigaRanD application and I will move some files into the pictures folder also. Now I will execute the sample ransomware called payload. Here we got a new notification from the application. It says that a ransomware attack has been detected. Now we can see that all the files were encrypted within few seconds, but my tool was able to identify the attack before the encryption. Here we can see a readme file from attackers. They are asking for a ransom to get back the data. If I search for the ransomware sample I ran before, we can see what are the activities it was done. Here we can see the starting process of the payload, and then we can find a huge number of file reads and writes that shows the encryption process of the ransomware. Now I will explain the code of GigaRanD project. This is the trace manager class. This class is collecting events, API events in the Windows system using a kernel parser. This kernel parser for this API events collecting, I used a library. This is the library I've used. This is a Microsoft. This library is offered by Microsoft Trace Event Library. Using that library, I was able to collect all the Windows events, file events, network events, registry events, process events, like that. All the events I collected to analyze. So if I scroll down from this start method, it is starting listening to the events, and after I start listening, I categorize those events into few categories. So this is process, start, process, stop, like that. I have categorized all the events into 24 categories: process, threads, registry events, like that. So if I go to the main model file, this file contains the main logic of the system. So it is creating a trace manage object to get the trace events. Then if I scroll down from this method, it is adding all the collected events into this temporary events list. After adding to the list, from this method, it is analyzing the collected events. If the analyze event list is contains 500 events, then it is analyzing. Then if any attack is detected, it will be alerted to the user. If no attack is detected, then it destroy those 500 events, and then again analyzing the next 500, like that. All the events are analyzed by 500 by 500. This is how my prediction is working. So after collecting data, it will count. After collecting 500 events, it is counting how much file events, how much network events, how much registry event, how much process events, like that. Then it is also counting how much file close event, register, process accept event, how much network connect event, how much file create events, like that. So after calculating those counts, it is creating the tensor, because I'm using TensorFlow for my machine learning. It is creating this tensor with all the counts. Then it will be passed to the pre-trained model, and if the model gives a value higher than 0.5, that means it is an ransomware attack. So then the user will be notified about the attack. So that's how the this desktop application is working. So another function, another feature I've added is to save feature, that as I previously showed in prototype explanation. This save function is saving the collected data into a CSV file, collected events. I have collected nearly 1 million of data by running my application in virtual machines. So after collecting those data, I saved those into CSV file, and then I uh, trained this machine learning model to identify ransomware attacks. For the model training, I've used Google Colab for that. So I've loaded the CSV file like this. Then these are the categories that I rolled previously. There are 24 categories here. Then sorry, then I created a sequential model, and for the model activation I used sigmoid because there is only one output I needed. There are no multiple outputs, so because of that I created the sequential model with sigmoid activation. So after training this model, I saved this model into a file. Then this file is loaded in at the running time of this desktop application. So if I search, yeah, here load model, that previously trained model is loaded here for the prediction, this keras model. So then I was evaluated and got the accuracy of 93%. These are the confusion metrics. So this is how my system is working. I benchmarked my system with currently available ransomware detection systems. In this video I am showing how I benchmark my system with Kaspersky anti-ransomware tool. Kaspersky is the world's top rated ransomware detection tool. So my tool was able to detect the attack before the Kaspersky is detecting. So my benchmark results showing that my tool, the GigaRanD tool, is 4 times faster than currently available systems. Number of domain experts, industry experts, and some undergraduates were evaluated my system. This is what evaluators are saying. If I talk about the contribution of the research, I submitted a review paper on a review on ransomware detection systems, and I was able to implement a high performance real-time ransomware detection system. And this GigaRanD tool is an open source project, so open source community can continue my project and improve the accuracy and performance. So I contributed to the open source community, and also I published an ransomware detection data set. These are the future enhancements that can be done. So main one is the prevention of attack. Many evaluators also mentioned that there should be a way to prevent the detected attack, and collect and add more data to the dataset from many number of real computers. For this prototype version, I collected data only from virtual machines. So for a more accurate detection, it is better to collect data from real computers. So it will increase the accuracy, and accuracy can be more improved by integrating a sandbox environment that we can test the detected process in a sandbox environment, and then analyze the behavior of that process. Those are the future enhancements that can be done.